Hi everyone, in today's video we're going to be covering the last new material for the chapter. Now I know a lot of this may be familiar to many of you, but I am going to ask you to still make sure you take notes on this so we make sure we all have a common understanding of this last piece. So what we're going to be doing is we're going to be translating, right? Really changing from one language to another. So we're going to be taking English sentences and phrases and translating them into math, which means we're going to be really translating these into algebraic expressions and equations. So at the top here, it gives us keywords, the most common keywords you'll probably see for all of our different operations. Now, I'm not going to read through those. You guys can take a look at that table here, but we will reference it as we go through the different examples. So let's go ahead and jump in, and then like I said, we'll go back and forth and look in the table as needed. So for this first part, we're going to be translating the following verbal phrases into expressions. Now remember, when we're thinking about our vocab here, expressions means no equal sign. So none of the phrases we're going to be translating here will have equal signs in them. So the first expression we have is the difference of 9 and a number. Now, obviously my key word here is difference, and if I go up to my table, I notice that difference is subtraction. Now, I know that order is an important thing to keep in mind for subtraction, so I'm going to make a note. For subtraction, order is important. And here's what that means to me. If this says the difference of 9 and a number, I'm going to call my number n. That's what I'm going to use my variable. That means that 9 must come first in my expression. I know I'm doing the difference, and my number comes second. So just like the order was here in the phrase, I'm going to use that same order in my expression. All right, for number 2, my keyword here is quotient. And if I look up in my table, I can see that quotient is a keyword for division. So here I'm taking the quotient of a number, again I'm going to call that n, and 22. Now, just like for subtraction, I'm going to make us another note. For division, I know that order is also important. Now, we could write, since the number comes first, I could write n divided by 22. That would be a perfectly fine expression, but since we've kind of moving into algebra now, I want to show it to you like you're most often going to see it, and so really we're going to write these as fractions. Since the number came first, it goes on the top. 22 came second, so it's going to go in the bottom in our denominator. All right, the next one, we have the sum of 57 and a number. So sum, I can see up here, is a keyword for addition. So I have the sum of 57 and a number, which again we're going to call n. Now, for addition, order is not that important. So I just went in the same order that I read this, but I just want us to know n plus 57 would also be an acceptable expression here. All right, for number 4, this is probably one of the most commonly missed phrases when we're talking about translating, because our keyword is actually this little word here, which is of. If I look in my table, I can see that of is actually a keyword for multiplication. So above that I'm going to put our little x, even though we're not going to actually write that when we write our expression. So in this case, I have 2/3, and I have my number, which I'm going to call n. Since I'm multiplying those, I'm going to use our algebra standards and just put that coefficient right in front of the variable. I know when those two are right together that that means multiplication. All right, now the next one, 5, gets a little trickier. I've got a couple things going on here. I see 8 times. Well, I know times is multiplication, but now here I have this, what says quantity. And I know that quantity means I need parentheses. So what's going to happen when I see quantity is that the stuff that follows is going to go inside parentheses. And now I can see inside I have 4 plus a number. So here's how this is going to look. We said we're going to have 8 times. So what I'm going to do is take my 8, and then this is going to be kind of my times the quantity. Then everything that follows there, my 4 plus n, is going to live inside those parentheses. All right, number 6, I actually want to go back and add something to our table. So here I see 3 times the sum of 7 and a number. This times the sum of, I'm going to actually add to our keywords for parentheses. So when I see times the sum of, I also am going to need parentheses. So just like with quantity, when I see times the sum of, everything that follows is going to live inside those parentheses. So in this case, I have 3 times the sum of tells me parentheses. Now, since this was sum, which is addition, that means I'm adding to these two things. So I have the sum of 7 and a number. Okay, now for number 9, I have the difference. So right away, I'm saying difference is subtraction. And I'm remembering that order is important. So I have the difference of 22 comes first. So I have 22 minus. Now I see the square of a number. The square of a number, right, means I have an exponent of 2. So in this case, I have my number, but I'm taking the square, which means it has an exponent of 2. So I'd have 22 minus n squared. All right, then for number 10, I have the quotient. We talked about quotient. We said that was up here for division. So I know I'm going to have division. And I'm dividing the square of a number. So again, that came first. That's going to live in my numerator. We just said the square of a number is n squared. And then 5 is going to live down in the denominator. Okay, let's go ahead to the next page. Now, I am going to put a star actually by less than because I see what's coming up, and this one something tricky happens. So let's look at number 11. In problem number 11, I'm asked to translate 18 less than a number. So I know less than is subtraction. However, when I use less than, that actually flips the order of the things I'm subtracting. So instead of following the normal order, I'm going to switch. So I'm going to start with my number, and I'm taking away 18. Right? If I want 18 less than something, I start with the something, and I take away 18. And that's why that order gets flipped. All right, at this point, we'll go over the next 3 examples in class, and we'll move on here. We've, at this point, remember, just been translating expressions. So now we're going to look at what it would look like to translate some equations. Now again, remember that an equation is a mathematical sentence formed by placing an equal sign between 2 expressions. So for example, all those things we've been solving so far, I can do a basic one, 3x equals 12, and because I have the equal, that's an equation. Now for us, that key word that's going to tell us equals, we're going to be looking for the word is. That to us is going to mean equals. So whenever I see that word is, I know that I'm going to have an equation here. All right, so my directions here say to translate the following verbal phrases into equations, right? Tells me I'm going to need an equal sign, and then we're going to go ahead and solve the equation for the given variable. And again, I'm just going to keep using n for that variable to represent the number. All right, so let's look at this. I'm going to kind of divide this up. I know the equal sign is always going to happen when I see the word is. So in this case, under that is, I'm going to write equals. That kind of helps me keep track of both sides of the equation. So the left side of the equation is going to be this whole phrase. The difference of twice a number. Now twice a number, if I look back, I know twice means to multiply by 2. So what I need to do is take this number n and multiply it by 2. So I know that looks like 2n. So I'm taking the difference of twice a number and 8. Since difference was subtraction, my left side is going to be 2n minus 8. And now the nice part here is the only thing to the right of my is 12, so I'm going to write that here. So my equation is 2n minus 8 equals 12. So now we can go ahead and solve this. This is a good review of our two-step equations. I know the first thing I have to do is to move this 8, so I'm going to use inverse operations here to add 8 to both sides. When I do that, this is going to cancel. I'm going to get 2n is equal to 12 plus 8 gives me 20. Then to isolate that n to get it by itself, I'm going to divide by 2, and n is going to be equal to 10. Okay, for the next one, let's see. I'm going to look for this is. So here I have is. Now in this case it says is equal to, so it's even more kind of obvious. So I'll make a note here. We may see the whole phrase is equal to. But again, below that I'm going to put my equal sign. Now to the left I have the product of 3 and a number. I know that product is multiplication, so I really have 3 times my number is equal to, and again, since 21 is the only thing on the right side of my equal sign, I'm going to put 21 here. This is an example of our one-step equations. Again, since I knew this was multiplication, to undo multiplication, we need to divide both sides by that coefficient. When I do that, this is going to cancel, and I get n is equal to 7. So again, I think we'll leave the next two for class. We'll go through those quickly before you have some time to practice this in class. All right, please make sure you've not only watched the video, but have all those notes taken down. I'll check that at the start of class. See you tomorrow.